Good morning, grade 11 students. In this session, we're going to continue with our chapter regarding the pedigree, which is the chapter of genetics. So we're going to move to question number one in this session. The following pedigree corresponds to a family members affected by the color blindness disease. Color blindness disease, where individual 3, 4, and 7, they are affected. So before I start, what is the allele of the disease is dominant or recessive? So I have to go for individuals 1 and 2. Both of them, they are normal, but they gave birth to individual 3 and 4, which are affected by the color blindness disease. So it's recessive with respect to the normal dominant allele and it's masked. So خلينا نعطي النورمال هي N capital for the normal and ناخد C small for the color blindness disease. C small color blindness. So here in this pedigree we have 7 or 8 members including the fetus. So these members, all of them, they are either normal or they are affected by the color blindness disease. So whether they are normal it can be expressed in both homozygous or heterozygous. Why? Because the normal is the dominant. That it can be expressed both in the case of homozygous or heterozygous. So here individual 1 أكيد حيكون عنده N capital. Individual 2 أكيد حيكون عنده N capital. Individual 5 أكيد عنده N capital. Individual 6 أكيد عنده N capital. But individuals 1 and 2, they gave birth to 3 and 4, which are affected, and the allele of disease is recessive, so it should be CC, C small, and individual 4 should be C small and C small. So both of them, they are affected. So here in this session, so both of them, they are affected, C small and C small. So here we can deduce that both of them, they are homozygous, and they should inherit C allele from each of their parents. So here individual 4 inherits C allele from individual 1 and individual 2. And this can be explained by what? By that the parents, they are heterozygous, having genotype NC and NC. Some of you is going to use, for example, to determine the dominant and the recessive allele, the individuals 5 and 6. You can use them. 5 and 6, they are normal, but they gave birth to individual 7, which is affected. So the allele of disease is masked and it's recessive. Also, individual 7 is affected. So it has C small, C small. So these C small and C small, both of them, they are affected. So CC, and it should inherit C from each of their parents. So here their parent should be NC and NC.
Morning, sir.
Okay, let's continue with the part 1. Indicate the dominant and recessive allele. Justify your answer already with it. Give the symbols or designate the symbols already with it. This also specify the genotypes. Pay attention here. Sometimes I said specify the genotypes of the members of this family, and sometimes I said determine. Whenever I said determine or I said specify, in both cases you have to justify. Unless I told you to give indicate the genotypes of the members of this family. Whenever I said indicate, you give the genotype without any justification. Whenever I said specify or determine, so this you have to justify. Part 4, carry out, Cynthia, the essential factorial analysis to predict the risk, and I said here in ratio form, for the fetus to be blind. This time in the quiz, I ignore it. Sometimes you work all of that. I said if in ratio form, I ignore it if you work in the percentage. But next time, if anyone I ask in proportion and you solve it in percentage, I'm going to drop all the mark for this question. And it's for example, عليها 2.5. 2.5 will be eliminated. So this time I ignored this. This time, according to the work, I ignored it. But next time, anyone I'm asking for proportion, you work percentage, or asking for percentage, you work proportion, I'm going to eliminate the whole part. Okay? Now let's move to question number 2. This is an important question, so pay attention. So here we have this pedigree. We said that the above pedigree, it shows the blood groups of the members of certain family. The gene coding for blood group is found on the chromosome pair number 9 in human? Who can tell me? Chromosome pair number 9, is it autosomal or gonosomal? Raising your hands, please. Yes, Ram.
It's autosomal.
Autosomal. نحن عندنا الاوتوزومز هنا from chromosome pair number 1 till chromosome pair number 20.
22.
22. While chromosome number 23, it's the
It's
gonosomes,
gonosomal.
which are either XX or XY in the normal cases. So here it's found on chromosome number 9. Chromosome number 9 is one of the autosomes. That's why you can say the blood group transmission it's autosomal. Why? Because the gene coding for the blood groups is found on chromosome pair number 9. Who can tell me how many different alleles for the blood groups do we have? How many different alleles other than RAM? Yes, Tala?
A,
A,
B, and O.
allele A, allele B, and allele
O.
O. Okay, so Tala said that we have three different alleles, A, B, and O. So Tala has a family history with the blood groups and as a history of the blood groups in grade 8. So here, blood groups A, B, and O has these three alleles. Let's start first with the questions. First, is the transmission of the blood group autosomal or gonosomal? Justify your answer. Since it's found on the chromosome pair number 9, so chromosome number 9, it's an autosomal, so the transmission is autosomal. So this is the first part. It is autosomal. Second part, among the alleles A, B, and O, specify the dominant and the recessive alleles. Let's look to the pedigree. In the pedigree, we have the solution. So pedigree, individuals 1 and 2. Individual 1 has blood group A. Individual 2 has blood group B. Individual 3 has blood group A. 4 has blood group O. 5 has AB. And 6 is the fetus who don't know what is the blood group. So Yusuf, determine the dominant and the recessive alleles. Tala said that we have three different alleles. We have allele A, we have allele B, and we have allele O. Three different alleles, A, B,
B,
and
O.
O. So, can you determine using the pedigree which of the alleles is dominant and which one is recessive? Justify your answer.
Okay. Let's see.
Yeah, look at the pedigree.
Okay. بما إنه parents, as the parents don't have O,
First of all, parents, they are blood group what?
A and B.
So blood group A, obligatory, it has the allele A, sure?
Yes.
And individual 2 has blood group B, so sure has has the allele B. Okay,
B.
now? So,
But they passed
but they
individual
gave birth.
4, but they gave birth
So
to
individual 4 has
which
blood
has
group.
blood group O,
So the allele O was
recessive or masked.
masked in the parents. So it's recessive with respect to the alleles A and B. So individual 1, sorry, has genotype what? Has genotype A, O.
AO.
Individual B has genotype B,
BO.
BO. Very good. Thank you, Yusuf. So here, individual 1 has genotype AO, and individual 2 has genotype BO. Lash, and Ali Yusuf, individual 1 and individual 2, individual 1 and 2, they have blood groups A and B respectively. But they gave birth to individual 4. This individual 4 has blood group O. So the allele O, it was masked in the parent. It's recessive with respect to the alleles A and B. طب بس انا سألت individual 4 يا حسين زيدان. Individual 4 has blood group O. What is the genotype?
O.
O, justify.
Because it is recessive and it can only be shown in homozygous form.
Very good, because it's recessive and it can only be expressed in the case of homozygous. تمام. So individual 4 طلع عنده OO, individual 1 طلع عنده AO, individual 2 طلع عنده BO. طيب individual 5. What do you think يا هاني؟ طلع عنده individual 5 blood group AB. So how can you explain this?
It took an allele A from the father and allele B from the mother.
Okay, so the genotype will be,
AB.
so which one is dominant and which one is
And
recessive?
since both are dominant, so both are expressed.
Yeah, this is the case of what?
Codominance.
Co-dominance. Very good. So this is the case of co-dominance. يعني اللي عنده blood group AB عنده both alleles A and B, they are dominant. يعني both of them they are expressed. So this is the case of co-dominance. While individual 3, what do you think, Yelena? عنده blood group A. What is the genotype?
A.
Okay, what is the genotype?
A O. Only
Or
A O, cause B is dominant.
AO or
A A.
AA or A O, right?
Yes.
Okay, great. So either AA or AO. So Lynn, أنت قلت AA or AO. But A should be inherited from one of the parents and O should be inherited from one of the parents. So إذا أخذ A من هون التاني وهون في
صح. Only A O.
It's only AO. It can't be AA. Impossible. Why? Because other individual has BO. من وين حيعطيه الA؟ ما حيعطيه الA. So this one is impossible. It's only AO. ما في إلا يكون AO. It can't be AA or AO. طيب fetus كيف بدنا نطلع له الريسك؟ هلا بنشوف using the pedigree. So here among the alleles A, B, and O, specify the dominant and recessive, perform the essential factorial analysis to predict the risk of the fetus 6 to be of blood group AB. So let's start. First one, they said autosomal or it's gonosomal. First, it's autosomal. Why? Because the gene coding for the blood group is found on chromosome pair number 9. Alleles A and B, they are dominant over the allele O, which is recessive. So while they are co-dominant both of each other. Why? Because parents are of blood group A and B. They gave birth to individual 4 or child 4, which is of blood group O. Then this parent must be carrying the allele O, but it was masked by the alleles A and B respectively. So alleles A and B, they are dominant over the allele O, which is recessive. Moreover, they gave birth to a child of blood group AB. So both alleles, they are co-expressed, meaning that they are co-dominant. Part 3, what they want? They want to perform the essential factorial analysis to predict the risk of the fetus to be of blood group AB. Meaning parents of fetus. Parents, they are individuals 1 and 2. So let's start step by step. Factorial analysis. First, we have to start with the phenotype. Phenotype of the parents. So the phenotypes of the parents, here we're talking about blood group. So we have male crossed with female. Male has blood group A. You can put it between these parentheses, blood group A, and female has blood group B. So here between parentheses, blood group B. Then we move to the genotype. Genotype for the male, it has A and O. And for the female, it has B and O. How did we get BO or how did we get AO? According to the pedigree. Then we move to the gametes. Gametes of the symbol gamma. So these gametes we have in the male and the female. In the male, we have A and we have O. Here I'm going to work it in proportion. I want to work it in proportion. So half, half. And then the female, we have B and O. B and O. Also, it's half and half. So here we'll finish first the table. We still have the table of cross and the table of result. They ask you to determine or to predict the risk of the fetus to be of blood group AB. So pay attention to this part. Then we move to the table of cross. Table of cross, very easy. Draw the table of cross, show using a pencil and a ruler. So you have to divide it into two. The male we have 2 gametes, and in the female we have also 2 gametes. And in this one we have to divide it into male and female. And in this male we have what? We have the A, it's half, and B, it's half. And in the female we have B, which is half, and O, which is half. So here, A and B, so it's AB. Half times half, so AB, it's 1 over 4. BO, O is the dominant is first, 1 over 4. And AO, it's 1 over 4. And OO, it's 1 over 4. Moving now to the table of results. In the table of results, we have to divide it into both genotype, and phenotype. So I'm going to write geno and pheno to make it faster. Geno and pheno. Okay, genotype. So we have in the genotype AB, it's 1 over 4. And we have BO, it's 1 over 4. And also we have AO, it's 1 over 4. And OO, it's 1 over 4. So AB, it's 1 over 4. BO, it's 1 over 4. AO, it's 1 over 4. And OO, it's 1 over 4. So AB 1 over 4. So the phenotype 1 over 4, the blood group will be AB. BO, so 1 over 4, the blood group will be what? It will be blood group B. AO, so 1 over 4, the blood group will be A. And OO, so 1 over 4, the blood group will be blood group O. So here, so the risk for the fetus to be of blood group AB, so the risk for fetus to have blood group AB is 1 over 4. So the risk for fetus is 1 over 4. If I told you, for example, blood group B, so it's also 1 over 4. If I told you, for example, blood group A, it's also 1 over 4. Or if I told you blood group O, so it's 1 over 4. So here we finish this exercise. So here we determine the risk for the fetus to have blood group AB, which is 1 over 4, and we determine it using the proportion. Some of you is going to use the percentage if they didn't mention in the question, or they didn't force you to use either percentage or proportion. So here AB 1 over 4. So here normally you can use, for example, instead of 1 over 4, it can be 25%. So here this is related to the risk of the fetus to be of blood group AB. Sometimes we're going to move in the coming sessions and in the coming lectures, we are going to talk about the sex-linked diseases. What the meaning of sex-linked diseases? They are not autosomal, meaning that they are transmitted either through the X or through the Y chromosome. This is the meaning of the sex-linked diseases. So these diseases, they are found only either on the X or on the Y chromosome. And this is the meaning of the sex-linked diseases. So here we finished everything related to the lecture here of the solving the exercise for this